Chapter 17, Ratios, Proportions, and Proportional Reasoning. A ratio can relate to one part of a whole, such as 9 girls to another part of the same whole, which is 7 boys. This can be represented as 9 over 7, meaning a ratio of 9 to 7, not 9/7 like a fraction. So a part-to-part ratio is not a fraction, although it can be written with a fraction bar. Ratios can be expressed and compared of a part to whole. For example, a ratio of a number of girls in the class 9 to the number of students 16. This can be written as 9/16 or can be thought as 9/16 of a class. Percentages and probability are examples of part-whole relations. Ratios can be written as quotients. If you buy 4 khakis for $1, the ratio of money for khakis is 1 to 4, or 1/4 as a quotient. Dividing the values, you get 25 cents per one. The unit rate is 25 hundredths. Ratios as rates. Miles per gallon, square yards of a wall covered per gallon of paint, passengers per busload, roses per bouquet are all rates. Rates involve 2 different units and how they relate to each other. The relationship between 2 units of measures are also called rates. Inches per foot, milliliters per liter, centimeters per inch. 10 miles in 3 days, 20 miles in 6 days, 30 miles in 9 days are all different types of units. Forming a ratio is a cognitive task, not a written task. That means that the ratio is a relationship and that relationship can be thought of different ways, regardless whether it's 2 fraction bar 5, 2:5, or 2 divided by 5. So we have examples here. Wand A is 10 inches long, wand B is 15 inches long. The ratio of the 2 wands is 10 to 15, or 2/3 simplified. To compare these, you could say the short wand is 2/3 as long as the long wand. The long wand is 3/2 as long as the short wand. So you could say how many times greater is one thing than another. What fractional part is one thing of another? When 2 different units are compared, the ratio is a rate. The term composed unit refers to thinking of the ratio as one unit. So we have 4 to 1. If you think that this is a unit, then you think about other multiples that would also be true. 4 is to 1, 8 is to 2, you double. You could also quadruple, 16 to 4, and so on. This is also called iterating. You can also use partitioning, which 2 for 50 cents, instead of doubling it, you're reducing it by 2, you're dividing it. Or you can find the unit rate, which is 1, is 25 cents. Activity 17.2 on page 438 provides the concept of thinking of a composed unit and then multiplication of comparison. Reasoning proportionally begins in kindergarten with 1-to-1 comparison, continues through grades with place value, fraction concepts, and multiplicative reasoning. Proportional reasoning is difficult to define in a 1 sentence or 2 sentences or 3 sentences. It is something that you either can or cannot do. Proportional thinkers do the following. Understand a ratio as a distinct entity that represents a relationship different from the quantities it compares. They recognize proportional relationship as a distinct from non-proportional relationships in real-world contexts, have a sense of convariation. They understand relationships in which 2 quantities vary together and are able to see how the variations in one coincides with the variation in another. They develop a wide variety of strategies for solving proportions or comparison ratios, most of which are based on informational strategies rather than prescribed algorithms. Remember, early ideas of proportional reasoning, 1-to-1 comparisons, such as place value fractions, compare situations and discuss whether it is an additive, multiplicative or a constant relationship. A ratio is a number that expresses a multiplicative relationship part to part or part to whole. The first situation is additive. Janet is still 4 blocks behind because they are walking at the same rate. The second situation is constant. It will take 8 weeks for the corn to grow. And the third situation is a multiplicative, and the answer is 12 ounces. The way to get students to distinguish between these types of reasoning is to provide opportunities for them to make both additive and multiplicative observations of situations and compare their responses. In the first case, the relationship is red equals silver plus 8, because the red car is 8 miles in front of the silver car. In the latter case, the relationship is 5/4 silver, because every 5 miles the red car travels, the silver car can travel 4. Covariation simply means that two different quantities vary together. Covariation simply means that two different quantities vary together. For example, 5 mangoes cost $2. As the number of mangoes varies, so does the cost. A ratio of two measures in the same setting is within a ratio. A between ratio is a ratio of two corresponding measures in different situations. The figure below is an effective way of looking at two ratios and determining whether a ratio is between or within.